Good evening, everyone. Success is not the key to happiness. Happiness is the key to success. If you love what you're doing, you will be successful. Keeping this beautiful thought in mind, a very good evening to one and all gathered here. I am Arun Kumar Ganeshan, your anchor for the fourth day of this International Faculty Development Program on Futuristic Pathways in Technology and Computational Methodology. Today's focus is on a topic of immense relevance: sustainability through technology, green computing. Each session so far has broadened our perspectives and enriched our knowledge, and today is poised to do the same. As we navigate today's session, let us immerse ourselves in the enlightening discussion about green computing, a domain that is not just a trend, but a necessity for a better tomorrow. Let us learn, question, and innovate together. Moving forward, I invite Ms. B. Shakti Maheswari, Assistant Professor, Department of Computer Science, to introduce today's chief guest. Ma'am, over to you.
Good evening to all. It's my privilege to introduce a remarkable individual whose contributions to academia, research, and innovation continue to inspire and lead. Dr. R. Jayashree, currently the Associate Professor and Head of the Department of Computer Applications at SRM Institute of Science and Technology, is a scholar and a visionary in the field of computer science. Dr. Jayashree's academic journey is a testament to her relentless pursuit of excellence. She holds a PhD in computer science from Satyabama Institute of Science and Technology, an MPhil in computer science from Periyar University, an MSc in computer science from Madurai Komaraj University, and a BSc in mathematics from Madras University. Adding another dimension to her achievements, she earned an MA in Yoga for Human Excellence, reflecting her belief in holistic development. With over 2 decades of teaching experience, Dr. Jayashree has mentored countless students, imparting knowledge in diverse areas such as artificial intelligence, data structures, software engineering, and machine learning. She has also spearheaded groundbreaking research, authoring several book chapters, and publishing extensively in leading international journals. Her accolades include prestigious honors like the Dr. APJ Abdul Kalam Award for Young Scientist, the C.V. Raman Prize, and the Best Researcher Award from SIFRE International Award, among others. She has furthered her impact by serving as a technical committee member for international conferences and guiding multiple research scholars in their academic pursuits. Dr. Jayashree's innovative spirit extends to patents in IoT and machine learning, highlighting her contributions to futuristic technologies. As an active participant in workshops, faculty development programs, and international collaborations, she embodies the values of lifelong learning and global engagement. Ladies and gentlemen, we are in the presence of an extraordinary leader whose dedication, achievements, and vision exemplify the true essence of innovation and education. Please join me in giving a warm and resounding welcome to our esteemed chief guest, Dr. R. Jayashree. Welcome, ma'am.
Thank you, ma'am. Thank you so much for your lovely introduction. Good evening, everyone. Can I share the screen?
Yes, ma'am.
I hope my screen is visible.
Yes, ma'am, it is visible.
Okay, right. So today we are going to look into the topic sustainability through technology, that is green computing. So I have planned a short session along with a small example program in Python. I hope the audience are the faculties, and I hope you know a little bit of thing regarding Python and machine learning and AI. And even if it is not so, it's not a big issue, because we are going to learn something more important today, important for the world, important for the environment. So these are the agenda of today's session: promoting sustainability through green computing, and we are going to look into, especially we are going to focus on AI and ML in predictive energy saving algorithms, and then we move to edge computing, green AI, and circular IT. So these are all the agenda of today's session. So innovating for a sustainable future. Right, so promoting sustainability through green computing, we are going to get into what is green computing. So first I want to emphasize on the importance of today's session. From research point of view, AI and ML are slowly losing the grace, and environmental awareness related technology are gaining attention. I hope everybody will agree to this. And the budding researchers, so you can make a note of it, and you can concentrate, you can divert your research work towards environmental related thing, sustainability related thing. So that will definitely, that will add weightage to your work and your papers, and your work will also get recognized, and your papers will also get published easily. So today we are going to discuss on how the well-known ML can be blended with sustainability in short. Now, what is green computing? The practice of designing, using, and disposing of computing technologies in an environmentally sustainable way, so that it will not create any harm to the environment. So that is called as green computing. So the main purpose of this green computing is to save the energy. So how the energy can be saved? For example, we can use some efficient processor. So the processor it is not going to take much time for processing, so that the processing will complete, it will finish the task quickly, and it is going to consume very less number of energy, and also it is going to give it's going to be more efficient. Or we can also use some smart power management system. Okay, for example, we all buy the refrigerator or washing machine with 5-star or 4-star to save the power. The same way, same thing we can apply for IT industries, or when you are doing your project, right? And one of the main issues in environmental side is greenhouse gas emission, carbon footprint. Okay, so or we are storing all the data in cloud computing or in data centers, and this is one of the major challenge currently the world is facing. So by using the green computing, you can reduce this, and we can use the optimized IT infrastructure and e-waste reduction. So we can reuse the e-waste. Okay, as much as possible we can reuse the re-waste by using we can use the recycling method and all. And we can also use circular economy. What the circular economy means nothing but just like OLX. You are going to use the used or old items, we are going to reconstruct it, and we are going to use it in the computer field. Okay, so that's what the circular economy. So all these are binded under green computing. So I hope you understood what is green computing, the basic of green computing. So now we are moving to the next one, that is the benefit of green computing. Okay, so the benefit can be classified into 3 portions: from environment point of view, economic point of view, and social point of view. So from environment point of view, it reduces the carbon footprint, just now we discussed, and also it conserves the resources. And economic point of view, it uses lower energy cost, and it reduces hardware maintenance expenses. right? And from social point of view, it promotes of sustainable practices, and everyone will get the awareness of environment, to save the environment, right? So technology is driven green computing. So what is green computing? To save the energy, to save the earth, to save the environment. So all these things we have seen in the previous couple of slides. Now we are going to see how these green computing can be applied in your research or in your computer knowledge. So here the technology driven green computing, you can use some energy efficient hardware. For example, instead of using usual hardware hard disk thing, we can go for SSD or ARM processor. That is one way of reaching the green computing objective. And next one is virtualization. That is, we can use the virtualization, that is, instead of using the physical computing, we can use some consolidating servers, okay, so that it reduce the physical infrastructure. And then or else we can go for cloud computing. Okay, we are all using the cloud computing directly or indirectly, right? So this optimize the resource usage in centralized data centers. We are all using Google Photos, Google Colab, all these things. Okay, Amazon Amazon Web Service, all these are example for cloud computing. And then AI and machine learning. So this is what going to be our highlight. We are going to get into the deeper about AI and machine learning. Here we can use some predictive energy saving algorithms. So they say instead of using the usual algorithms, we are going to include some ingredients so that it becomes energy saving algorithms, right? And then IoT and smart grid. So it is used for monitoring and optimizing the energy use. We can use IoT and smart grid. So though we have these, in all these things we can apply the green computing concept. Due to time constraint, we are going to focus only on AI and machine learning. AI and machine learning in predictive energy saving algorithm. So here we are going to use some optimizing energy efficiency for a sustainable future. So now let us look into what is AI and what is ML, machine learning. So what is AI? AI is a simulating human intelligence in machine. And what is ML, machine learning? Is a subset of AI focused on algorithms that learn from data, right? So we all know this. And what is the importance of energy efficiency in AI and ML? So it reduces the cost and environmental impact, and it also optimizes the resource usage for sustainability, right? Are you all able to follow me? Please, you can clarify your doubt, or if you find any difficulty, you can feel free to ask me. And we all know AI and ML are popularly used for forecasting, for prediction, right? And AI and ML in predictive energy saving, the role of AI and ML in energy sector is forecasting the energy demand. Okay, so that is the main thing. And second point is for optimizing energy consumption and for predicting the equipment failure and ensuring efficient operation. Okay, so these are all the purpose of AI and ML in predictive energy saving thing from that point of view. So these are all the key applications. energy demand prediction, that is predicting the energy consumption based on historical data and external factors. Usually we use this AI and ML for predicting. We take some set of data and we will predict, we will forecast the data based on the previous pattern, right? So this is what we usually do by using AI and ML. So here we are going to predict, the same thing is applied, but by using the previous data, we are going to predict how much energy that particular program or that particular process may need, right? And next one is smart grid and load forecasting. That means here what we are going to do means we are going to optimizing the distribution and balancing the energy supply demand. Okay, so that's the purpose of this smart grid and load forecasting. And next we have building energy management system. So this is going to automatically, we all may be using the smart what we can say, the smart AC, okay, the smart washing machine. So what does it mean? Based on the load or based on the light, based on the heat, it is going to adjust itself automatically. Okay, the same way we are going to apply the same concept in the algorithm, AA algorithm. Okay, so it is going to dynamically, it is going to adjust based on the heat or ventilation or air condition, lighting, right? So that is what called as building energy management system. And we have other applications like predictive maintenance. So this is to forecast machine failures. So if any machine fails, then so that it will predict and the data will not get lost. And energy efficient data centers for optimizing the energy usage in cooling and server management and all, we use this energy efficient data centers. Okay, in data centers also we can apply this concept. And renewable energy forecasting, that is we can identify forecasting, that means predicting. Okay, predicting what are all the renewable energy, for example solar energy, wind energy. Okay, so all these are the availability of these things. So you can also do your project, your research focusing on renewable energy. So many open-ended projects, open-ended concepts are available under renewable energy. Now we move to the benefits of what is the use of predictive energy saving algorithm. So from environment point of view, it reduces the carbon footprint and it manages the resources efficiently. And of course, since it manages the resources efficiently, it reduces the costs. Okay, because we are going to reuse the same product or we are going to use the thing efficiently, right? And then the operational efficiency, that means it enables the smooth operations with predictive adjustment. So before any problem comes, we are going to predict it so that the operation can be done smoothly. And scalability, so it can be applied across all the things like residential, commercial, industry, transportation. So wherever we want, we can apply this concept. So not just for from the computer point of view, not just for research point of view, AI and ML point of view, we can apply this green computing concept in our daily day-to-day life. Okay, that's what the scalability represents. And then what are the challenges in implementing the predictive energy saving algorithm? So far we learned what is green computing, what are the benefits of green computing, and we also learned that this can be applied in our research point of point of view, and we can apply in our AI and ML prediction algorithm also. So all these are, we have just seen the positive side of green computing. Now we are going to focus on what are the challenges are there. So we need a data, the quality data. The data should be clean and comprehensive. Only then we will get the accurate prediction. So green computing, for everything there will be a positive side as well as some portion of negative side. The same way here also in green computing, it reduces the resources, it reduces the energy, okay, energy consumption, everything. But the negative side is it will not give the accurate data. Okay, so the accuracy will not be as accurate as when you are using the non-green AI. Okay, and next one is complexity. So this is again another challenge. So building and maintaining the predictive model is going to be little complex, and integration issue. Okay, so adapting the existing system to the sustainable format is going to be take some time. So that is the integration issue. So these are the three common challenges we face when we are using green computing. Now we are moving to the second portion, the future of green computing, edge computing, circular IT, and green AI. So we are going to look into these models one by one. So generally the green computing is used for renewable energy powered data centers like Google, Apple. Okay, they are all using the green computing concept in order to reduce to save the environment. And then we can also, under it we also have edge computing. It reduces the data transmission energy. And then circular IT is fully sustainable device design. So overall the IT industry, okay, information technology, IT industries are going to use the sustainable devices. So that is why it is called circular IT. So everything is going to be recycled, everything is going to be reused. And next one is green AI, where we use the energy efficient machine learning model. Okay, so we are going to look into these things one by one. The first we move to the edge computing. Edge computing is mainly for transforming the future of data processing, right? So what is edge computing? So before getting into the edge computing, can anyone answer me the advantage of storing the data in hard disk and advantage of storing the data in main memory or in cache memory? Which is more easy from a CPU point of view? When the CPU wants to process, when the CPU wants to take the data, from where it can take the data easily? From hard disk or from the main memory or from cache memory?
From cache memory, ma'am.
Why?
Because the access time will be faster. Recently used data will be saved in cache memory. So it will be easy to access. In main memory means all the data will be stored. Then to find it and to search it and find it, and then only we can use it. Hard disk means it will hold all the softwares and details, everything. So it will be huge. So searching will take some time.
Very good, very good. I don't know who has answered, but we can give a very good answer. So that is what the concept behind edge computing. So instead of storing the data, so what is edge computing? It is a distributed computing model. Okay, it is a distributed computing model. That it is not a centralized one. It is a distributed one, and this is going to bring the computation and data storage closer. Okay, so it is going to make the computation and data storage to be closer, so that, so what are the advantages? Just now she told everything is applicable for green computing. You can search easily. So it will reduce the time of searching and it can process efficiently. Okay, so all these things. So just remember what answer she gave. That's what applicable for edge computing. So usually we will store the data in the cloud or in the data center. So fetching the data from the cloud or data center for our purpose will take more time. So this is something similar to fetching the data from main memory or from hard disk. There are huge number of data. Okay, so what we are going to do, the data is going to be transmitted to the local device, which is closer for accessing. So it will be very easy for accessing, and this will also provide some security, because instead of storing the data here and fetching the data, it has more risk factor, right? It has to transmit through various networks. But if it is very closer to the device, which is very closer, okay, somewhere, so here you are going to have your data, so you will be getting the security. Data security will be there, data will not get lost, and you can fetch the data easily, you can retrieve the data easily. Okay, the time period will get reduced. So that's the purpose of edge computing. Okay, so let's look into the slide. Based on the slide, okay, so edge computing transforms the data processing by reducing the latency and enhancing the security. Okay, so here huge number of data, searching the data will increase the latency, latency. Okay, the space is huge, so searching a particular data will take more time. Here the space is small, so searching a particular data will take less time. So that's what here it means. Okay, it reducing the latency, and this also enhance the security, because we are not going to store the data along with the other data. We have separated the data, and our own data or the very sensitive data alone will be placed here. Okay, so that will enhance the security. And then we have a complementary model to, so this is edge computing is nothing but it is a complementary of our cloud computing. Instead of taking from the cloud computing, we are using in between, we are using edge computing. So this is an added advantage for cloud computing. And then edge computing adaptation is pivotal for technologies. Okay, so this is the main thing for the technologies like IoT, AI, and 5G and all. So these are the key features of edge computing. First one is it processes the data closer to its origin. So that's what the first thing represent. So it processes the data closer to the origin. Okay, so it will be closer to the origin, and it is going to use a decentralized architecture. Okay, so from the centralized one, it is going to fetch the data and it is going to keep it in a distributed format. So here it is a centralized, and here it becomes distributed. Okay, so it is a distributed. So it shifts the computation from centralized data centers. From centralized data centers, it is going to distribute the data to the local devices. Okay, so that's what the decentralized architecture. And it also enhances the privacy, because local processing, it minimizes the data transmission risk, isn't it? So here the data transmission risk is very low. So thus it will increase the security also. And then resource optimization, it filters the data locally and saving the bandwidth. Okay, so it also reduces the bandwidth. So all these are the advantages of, these are all the key features of edge computing. So from advantages we can say the same thing. It reduces the latency so that it will reduce the time period. Okay, so we can use, so that edge computing can be used for time sensitive application, some real time application where we bother about the time. In those application we can use edge computing. And it also improves the process the data locally. Okay, it improves the efficiency because the data are going to stored in the local device, so that it can be processed quickly, right? And then it is also going to save the bandwidth. Just now we learned about this. It saves the bandwidth because it is going to send only the relevant data to the cloud. Okay, not all the data. So it saves that bandwidth. And then it is going to function during so what the third point, fourth point says means, even if the network outrages, if network fails, okay, even then it will function because the data are stored in the local device only. Okay, so even if you don't have the network, by using the Bluetooth or some other thing, you can get the data, you can fetch the data. So that's what the fourth point represent. And it also minimizes the exposure of sensitive data, so that it enhances the security. Okay. And so these are all the applications. We can see the applications of edge computing. Okay, before going into the edge computing, so edge computing can also be used in various real-time examples. For example, it can be used in smart cities, something related to local. Okay. For example, in traffic management system, they are using so that also comes under edge computing only. Traffic management system, okay, or you can say that like smart lighting. When the persons are there, only that time the light will glow, right? So all these comes under the edge computing only. And similarly in agriculture and all, we can use, by using the IoT, you can identify the moisture of the soil or the weather condition. Okay, so by using the local data, what are the things you can do by using the local data? Okay, all these things comes under edge computing. Okay, or we can also use some if it is a company or some automobile company or something like that, then in order to control the quality control, real-time quality control can be done by using the edge computing, or identifying whether the machine got breakdown or not, the function of machine can be monitored. So all these things comes under edge computing concept only. Okay. So you can also do a lot of research work based on edge computing. And if you have a little bit of knowledge in IoT, then that will be a added additional thing for your research work. Now we move to the green AI. Okay. So what is green AI? Building a sustainable future for artificial intelligence. So we learned about edge computing, but edge computing, if you are using some IoT or some embedded system, then you can do the projects or research work based on edge computing. But this green AI, here we are going to learn about machine learning and AI algorithms including blended with the sustainability. Okay, that's what the green AI, this is the main focus of our session. So what is green AI? Actually we have two AI, red AI and green AI. Red AI means what algorithms so far you are using in AI and ML, everything comes under red AI, because we are not bothering about the environment, we are not bothering about the sustainability, we just focus on the accuracy. So you can see that there are so many, plenty of papers are there by using the CNN, machine learning, AI, deep learning, everything. And most of the papers, they focus only on the accuracy. So far, what are the things you learn comes under red AI. Okay, it concentrates only on accuracy and not bothering about the efficiency, or not bothering about the environment. Now we are going to green AI. What we are going to learn is green AI. So what is green AI? We are going to use the AI model only, AI algorithm only, but we are going to use energy efficient algorithm. We are going to make some slight changes in the algorithm so that red AI will become green AI. Okay, we are going to make some small changes in the algorithm. Okay, so thus what are the things we learned in green computing? Once your red AI becomes green AI, it will satisfy all the green computing necessary things, and it becomes environmental friendly. Okay, and it promotes the sustainability, and it reduces the carbon footprint, and optimizing AI model for better energy efficiency is a growing area of interest. Okay, so what are the focus area? What are the key points that comes under green AI? It is going to reduce the energy consumption. It is going to use the optimized computational resources. It is going to use the optimal number of computer resources alone, and it is going to reduce the carbon footprint of AI model. Okay. So these are all the key concepts in green AI. So any energy efficiency, we are going to use some optimized algorithm so that it reduce the power usage. And also we can also use some energy efficient hardware. As we learned, we can use some ARM or SSD for efficient processing, and using the resource optimization, that is minimizing the memory and storage need. And we are going to leverage edge computing for local processing. Okay, we are going to blend the edge computing along with the green AI, so that we get better sustainability. And at last, sustainability metrics, that is evaluate the AI model using energy consumption and CO2 emission metric. So we are going to evaluate the AI model not based on only on the accuracy. We are going to evaluate based on energy consumption and CO2 emission metrics also. Okay. So these are all the green AI best practices. So it reduces the model size because it is going to focus on the number of parameters in model through pruning. What is pruning? Can anyone tell what is pruning? What is pruning? That is avoiding the unnecessary branches. Okay. So it will focus on a main branch alone. It will avoid the unnecessary branches. Okay, that is what called as pruning. Cutting the branches. Okay. Or by quantization. Quantization means reducing the quantity. See, suppose for example, you have a data. Okay, you have downloaded some data set from the Kaggle or some other repository. Okay, you are going to, for example, your research work is based on cardiac disease prediction. and you may have the data set something not related to your research work also. Okay, they may give some age, or they may give some the nationality, for example, okay, something like that. So all these are not necessary for your work. So what we will do, we will do the feature selection. We will select only the data which are needed. So unnecessary data we will just trim, we will just omit. Okay, so that is called as pruning. Quantization means, suppose for example in the data set there are 10,000 datas. Okay, so 10,000 datas are not necessary for coming to a particular conclusion. You think that 1,000 data is enough, or 5,000 data is enough. Okay, so now you are going to take only 1,000 data from 10,000 data. So you are reducing the quantity of the data. So that is called as quantization. Do you understand what is pruning? What is quantization? Okay, or we can also use some smaller architecture. Instead of using a very complex architecture for your research, you can make the architecture to be little smaller, and the efficiency is going to be the same one, equivalent one. Then you can use such kind of thing. Okay, so all these comes under model reduction, model size reduction. So we are going to reduce the number of parameters, either column wise or row wise or architecture wise. We are going to reduce the size. Okay. And the next one is hardware efficiency. As I said, we can use some efficient hardware. Instead of using ordinary CPU, you can use some GPU or TPU. Okay, so that it will enhance the efficiency of the processor, and you will get the output quickly. So that's what the hardware efficiency. And then we have distributed learning. That is, we can split the training process across multiple machines. So instead of using a single machine for training the process, and instead of overloading a particular machine, you can divide it and you can put it in different machines if it is possible. Suppose you are working in a college and there the LAN system is available, processors are available, more number of systems are available. So then we can distribute the data, and we can in multiple machines we can give that, we can train the process, and that will reduce the usage by balancing the workload efficiently. And then optimized algorithm, implementing the algorithms and techniques. Just now we learned about quantization or by using pruning, so that it will reduce it by implementing such kind of algorithm. Okay, so we can use those algorithms in both training and testing phases of your research work. Okay, and then by combining, so these are all the things. So we can use any one, or we can also combine any of these in any format. We can combine, so that we can reduce the carbon footprint, and we can get the energy efficient model. Okay, so these are all the key concepts: early stopping, model pruning, and optimization of training time. So these are the three things which can be used for converting red AI into green AI. So how we can convert red AI into green AI? In your algorithm, if you apply any of these things or all the things, okay, it's up to you, then the red AI will become a green AI. So here is a code. I have this program. So in this program, we are using green AI. Okay. This is for green AI. And this is for red AI. So I have pasted the code. I hope you all can see the screen, right? I have shared the entire screen. You all can view the screen, no? Google Colab.
Yes, ma'am, it's visible.
Okay. So I have pasted, I'm running two programs. One is for green AI and other is for red AI, and I'm executing both the programs. Let it get executed. It will take some time. Okay. In the meantime, let's look into the remaining part of the session. So this is what we have done in the red AI. Okay. So just to make the identification, I'm calling it as red AI. So this is nothing but the code, usual program. You all know without using the green AI technique. Okay. So that's what the usual program. So here, what we are using, what we are doing. So in this example, we are taking a data. So this is nothing but a modified National Institute of Standards and Technology data set. Okay, ma. So MNIST means this is the modified National Institute of Standard and Technology data set. It is available, freely available in the internet. So I have taken that data set. And usually what we do, we pre-process the data, we convert the data, convert the labels to one-hot encoding. What is the purpose of this one-hot encoding? Can anyone tell me? Why we use this one-hot encoding? Yes, one-hot encoding is to convert categorical data into numericals. Okay. So that it will be easy for us to make the classification. So one-hot encoding will convert categorical data to numbers, numericals. And then we define a simple CNN model and we compile the model, we train the model, and then we evaluate the model. Okay, so in this program, so this is the expected output. Okay, let's find whether we are getting the expected output. So in this program, we have given it has 20 epoch. So 20 times it will execute and we will be getting the output something like this. We expect the output to be like this. Okay. If time permits, I will explain the program also. So here, there is no early stopping, there is no model pruning. Okay. Right. So this is this version will purely focus on training a standard CNN model without any energy saving optimization. Okay, and it is going to execute. I have set it as 20 epoch, and all the 20 epoch it will execute, and there is no pruning, there is no stopping, early stopping. So until it finish 20 epoch, it will execute. Okay, and then we move to we are going to do the same program. We are going to apply pruning and early stopping, so that the same program becomes a green AI program, energy efficient program. I am going to take the same data set. We are going to pre-process the same data. We are going to use the one-hot encoding again to convert categorical data to numericals, and then we are going to define a simple CNN model. We are going to compile the model, and then you can see here we are going to use early stopping. So what is early stopping means? If there is no improvement, or if there is very slight improvement, for example, if the previous data is 0.9741, okay, and then the next data is 0.9742, so that means very small improvement. So that is not going to affect my decision or my prediction to a great extent. Okay, so that is what, in that case, it will stop the execution. That is what called as early stop. Do you understand the difference between mathematics and statistics? Mathematics, it concentrates on the precision. Okay, what the statistics we do? In statistics, we make the comparison whether one is greater than other, whether one is better than other. So in statistics, we will not be more precise. We don't want to be much precise. Okay. But in mathematics, even 0.1100, that is much important. So that makes a difference. So here in green computing, when you use early stopping, if the improvement is very small and that is not going to affect your performance of your program, efficiency of your program, then it will stop at that point itself. So that is what called as early stop. Understood? Yes? Do you understood? In the previous, we gave 20 epoch. Whatever may be, it will execute 20 epoch because we have given. But here, what it will do automatically, if there is not much improvement from one epoch to other epoch, then it will stop the performance before reaching 20 epoch. So that is what called as early stopping. Do you understand? Can I move to the next one?
Yes, ma'am.
Okay, so now we are going to, we need to train the model with the early stopping and we evaluate the model. And similarly, we use the pruning. What is pruning? We will cut the branches, okay, unnecessary thing, or we will concentrate on only one particular thing and we will just omit the remaining thing. So that is what the pruning. We will do the pruning and we will train the model with early stopping and we evaluate the pruning. So here you can see we will be getting in 6 epoch itself it stops. So this will differ from one system to other system or one program to another program. Let's see in what epoch our program stops. Okay, right. So the difference between the two versions, the primary difference in the output between the two versions of the code lies in the training duration and model performance. So if you are concentrating more on, see for example, from training duration point of view, okay, in green code, in green AI code, what happens? It will take less time to training because we are using early stopping. Okay, so it will not take much time. It will stop in the once it reaches the early stopping point. And additionally, model pruning will reduce the number of weightage in the model so that it makes it smaller and quicker to process during training the inference. Okay. But as I said, it will print fewer epoch in the training log as the training process may stop early before reaching the 20 epoch. So from test accuracy point of view, you may get slightly little accuracy in your program. Okay, very little slight accuracy difference may be there, but that's not going to make a very big impact. Okay, and in case of green AI, it will execute all the 20 epoch, and it will take so here what happens, one of the drawback in usual AI is overfitting. Okay, but in green AI we will not face overfitting. There will not be any overfitting problem at all. Okay, in green AI there is no overfitting problem, whereas in usual AI, in red AI, you will be getting overfitting problem. Okay, so that is one of the thing. And from model size and efficiency point of view, we are using pruning, so the model size will be reduced one, and you can also use resources efficiently, that is when you are using the GPU, TPU and all, so it will use it efficiently, whereas all these things are not available in standard code. Okay, that is in red AI we don't have all these things. And then from overfitting and generalization, so in AI, green AI, there is no overfitting at all, because we are going to use early stop. So there is no chance of getting overfitting. And also it is going to train the data, and it is going to produce the very less number of epoch, and unnecessary parameters, all these will get pruned. Okay, so all these are advantage of green AI, whereas all these things are not available in the non-green AI, that is in red AI we don't have all these things. And from accuracy point of view, as I said, slightly the accuracy may be lower in green AI compared to red AI, but that is not going to be it's not going to have a huge impact. Okay, it's going to be very minimal accuracy changes will be there, so that can be compromised. Okay, and energy consumption. Okay, so when your program is going to finish quickly, or when the program is not going to execute the very complex things, then automatically the energy consumption of green AI is lower than the red AI. Okay, so all these are the advantages. So so as a summary, we can say that green AI version, it is slightly lower in test accuracy, but it is more efficient in terms of energy consumption, training time, and model size. Whereas the standard version, that is red AI, okay, the standard version, it may have some higher accuracy test, but it also equally it needs more computational resources and time for training. And also what is the main disadvantage in standard AI? Overfitting. Okay, so it is up to you to select whether you want to use red AI or green AI. According to your research work you can decide, but whatever my suggestion is, whatever research work you are doing, you just include this early stop and what is the next one, pruning. Okay, in your program, so that you can say that your program is sustainable. Okay, your program is going to use less energy, it is going to save the energy, it is going to reduce the carbon footprint. So all these things you can highlight in your work. Okay, so we are moving to the last part. So before going to that, let me check the output.
நாளைக்கு வந்து வாங்கிட்டு அடுத்த ஆஃபர் பிரியாணி வாங்கிட்டு அந்த இதுக்கும் சேர்த்து வாங்கிட்டு.
Okay, you can see here at the 11th epoch it has stopped green AA. It is still running. And when you execute, you can find that it will run all the 20 epoch. Okay, green AA it has stopped at 11th epoch, whereas this red AA it's still running. It's not, it got see this also. In the meantime, we will complete this program. So now we are in the last part of the circular IT. Okay, the last part of the session. Sorry. Right. So what is circular IT? In the IT field itself, we are going to use what is circular IT, just like circular cube. We are going to reuse. Everything will be reused. Everything is going to be recycled as much as possible. So that is what the circular IT. We are by applying the circular economy principles to information technology by reducing the waste, reusing the resources, and recycling all the IT products. Okay, so that's what the purpose of circular IT. So it promotes the sustainability by reducing the waste. Okay, and also it ensures that ethical disposal. So since we are dealing with e-waste, it must be disposed in a right way and embrace circular it to contribute to a greener and more sustainable digital future. So these are the key principles. So the main objective is to minimize the environmental impact, optimize resource use, and promote the sustainability. So it reduces the minimal resource consumption and energy use in IT field, and it is going to extend the life cycle of IT products by recycling it. Okay, and also we are going to from the disposed IT product, we can think what are the new things or new product can be built. So from environment point of view, this circular IT is important because it reduces the e-waste and also it reduces the greenhouse gas emission, and also it is going to conserve the natural resources. And from economic point of view, it is going to recycle almost every e-waste, so that economically also it helps, and it also provides new opportunity, especially when you are applying for projects or again your research work. If you are focusing on the e-waste management or waste management, okay, then that will give that will be more attractive, and you can get the projects or your research work will get approved very quickly, very fastly. And social responsibility, again, you have to, when you are dealing with such things, you have to be little careful. You should also know what are all the ethical ways of handling all these things. And if you are good enough in IoT, then you can apply your IoT knowledge in for e-waste management and all, and that will be very good for your research work. So circular IT practices, sustainable. We can purchase the energy efficient and eco-friendly IT products. If you are owning a IT company or a small startup, then you can go for circular IT practices. So whatever you are buying IT products, you can make sure that the product is not going to consume much energy. Okay, and you can track and optimize the IT equipment life cycle, right? And then we can also have a e-waste management, and we can shift the workload to share the energy efficient by using cloud infrastructure. So we can, instead of buying the IT product, we can use the cloud infrastructure. For example, software as a service, okay, or hardware as a service, platform as a service. Likewise, you can go with the cloud infrastructure, so that you can reduce the amount of e-waste. Okay. So these are the future of circular IT. Okay, we can use hardware as a service or software as a service, so that you can reduce the e-waste, and we can also use some modular and recyclable IT products, and we can also use some AI driven e-waste. So all these will enable circular IT. And these are all the challenges. So that's all about the circular IT. Okay. Let me check again the program. Is there any improvement? Yes. No, only 6 epoch. 7th epoch is going on. Now we are coming back to again the green computing. So today in the session we learnt about what is green computing, the importance of green computing, and under green computing we learnt about energy efficient algorithm which can be blended with AI and ML algorithms. And also we learnt something regarding the edge computing and green AI. What is green AI? What is red AI? And then we have seen a small program by using the by implementing the energy efficient algorithms, that is by using the pruning and early stopping, how to convert a red AI program, that is a standard code, to green AI code. And then we have overviewed circular IT. Okay, in IT field, when you are using everything, when we try to recycle, then it will become circular IT. Now we are getting back to the green computing. So what are all the challenges in green computing? Even though green computing is very it's very necessary in order to save the environment. Okay, but there are some challenges. Okay, it's not it also has some drawbacks. For example, high initial cost. Okay, so initially when you want to convert when you want to go for green computing, we need to make some small initial investment. And awareness gap. Okay, limited understanding of green IT practices. So we need to create an awareness. Okay, the importance of green computing among the society. Only then the people can understand the value of green computing. And then e-waste management issues. Okay, so recycling and the infrastructure or recycling the IT products, it has some there will be some management technical issues and also you need to, sorry. So we need to, we should also know what all the practical issues that may arise when we are using the e-waste management. So these are the 3 challenges we face when we are using green computing. So as an individual, how we can contribute? Okay, so we can use some energy saving, we can cultivate energy saving habit, and as much as possible we can recycle the old electronics. Okay, and to use the or we can dispose the things, at least we can dispose the electronics or e-waste in a ethical way, and as much as possible we can use the cloud storage. Okay, instead of storing it in a physical device, we can go for cloud storage. Of course, we are all following this, I hope so. And we can support the green companies. Okay, we can use the brand with sustainable practices so that every IT companies or every data center will go for green computing. And these are all the real world examples. So Google, Microsoft, Apple, Dell, you can see that every one of them, they started implementing that green computing in their data centers. And key takeaway, green computing, it balances the innovation and environmental responsibility. And we are going to it is a small initial step that leads to significant impact. And together we can create a sustainable technological future. Now, no, it's still running, but hopefully it will reach 20 epoch. Okay, 20 to 20 it will come, because this is a non-green. That is a red AI code. Okay, thank you all. You have any doubt?
Thank you, Dr. Jayashree, for an exceptional session.
Thank you, sir.
Dear participants, the Q&A session is now open. Please feel free to share your queries or raise your hand to engage with our speaker. You can unmute yourself.
Yes, participants, you have any doubt regarding this? Okay, hopefully I think you all, instead of using usual AI, you will implement early stopping and then pruning method in the AI program so that it becomes green AI. Yes, Arun Kumar sir.
Yeah, ma'am.
Yeah, is there any query in the chat box or anything?
No, ma'am. So far, no queries.
Okay.
We are truly grateful for the time and effort you dedicated to sharing your knowledge and expertise with us today, ma'am. Once again, thank you so much.
Thank you, sir.
Yeah, ma'am.
Can I leave the session, sir?
Yes, ma'am.
Thank you, sir, and thanks
Thank
to Shakti ma'am for the.
Thank you, ma'am. Thank you so much, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Dear participants, I have posted the attendance link in the chat box. Those who have filled the attendance link can leave the meeting now.